So here is the wiring diagram for our cheap diversity controller. I've got the ICs here. Now, the numbering is not normal because this assumes you've got your IC upside down, your chip is upside down, because we're going to be mounting them upside down on the piece of board so that they can be stuck to the board. It makes it dead bug style. So instead of going from 1 through to 14, they're actually numbered clockwise now because this is looking at it from beneath. So if you bear that in mind, all you've got to do is make sure you identify which is pin 1 on each of these chips, as you'll see later on, and then make sure you've just joined the various pins. So pin 1 gets joined to pin 6, and that also gets joined to pin 5, and in this case pin 3 gets joined to pin 9, and pin 4 goes off here to a 47 k ohm resistor and off to the pin 14, and it goes off to positive, the voltage you're running your system on. It's all pretty straightforward if you follow this. If you get stuck, just refer to this diagram and it will basically give you all the information you need. Over here we've got our RSSIs for video receiver 1, video receiver 2, video inputs for video 1, video 2, and there's our video output, and here's our plus and our minus, which I should actually draw in here because it is important. I haven't done it yet. Oh, you have actually. Here we go. This is minus. The minus is pin 7 on this chip, and it's actually pin 11 on this chip. That just means that those pins are soldered to the copper board, as you'll see when we start putting this whole damn thing together. So now it's back to the bench. Okay, so here's a sheet of the copper-clad board. This is the copper. It's old, it's all corroded. This is the stuff I've had laying around for years, and it's got all this corrosion in here, so I'm not going to be able to use this to make printed circuits, but I can use it for the dead bug building style. So that's what I've done. I've cleaned it up, got it nice and looking pretty shiny, as you can see, hopefully, nice and shiny, woohoo, which means it'll be easy to solder to. And I've got somewhere here, what have I done? Oh, yeah, I've got our integrated circuits. Here's one of the integrated circuits. This is a 324, and I'm going to show you something here. It's quite important that if you have a look at the little integrated circuits, you'll see on one end there's a little divot here. Oops, get it into shot. There's a little divot on the end there. See that little mark? It's kind of like a semicircle out of the plastic. If I tilt it over, you might be able to see it a bit better. Just there, see that? Oh, there we go. That little mark there enables us to determine which is pin 1, because we need to know what the numbers of the pins are if we're going to wire the right pin to the right component and so forth. So the way these things normally number is they go 1 through 7 and then 8 through 14. It's a 14 pin device. So this little divot means that pin 1 is directly below it, and then around you go. Now, we are going to be mounting these upside down. So what I'm going to do is when we flip them over, obviously this will become pin 1, or this will be pin 1. And because it's upside down, it will actually go clockwise. So it'll go 1 to 7, 7 to 14. And just so that we can remember which way around they go, I'm going to put a little black dot on the circuit board, which will denote pin 1. So we can remember, or we can work out what the other pins are. Simple as that. So let's get started. Or what I should mention too is I'm going to stick these to the board because I'm going to use some double-sided tape, like this is Sellotape brand. Put a bit of double-sided tape on there because I want these stuck upside down on the board so that they provide a nice base for holding everything together while we work on it. If we just let them be loose, then they'd wobble around. It'd be really hard to work. So sticking them down with double-sided tape means, you know, nothing's going to move. It makes it much easier. You could use CA or something, I suppose, but then if you want to get them off, it's a real pain in the backside if you make a mistake and you damage a chip or something. So just double-sided tape's probably a better way to do it. So I'll put both chips on there, mark pin 1, and then we'll move on. And here we go. That's exactly what I've done. I've mounted both the chips. I've got the 4046 here and the 324 there, and as you can see, they're not moving. They are firmly mounted to the copper by way of that double-sided tape, and I've started running some of the wiring to give you an indication of what we do here. Now, I've run the power wiring, and now both these chips require voltage to operate. So I've run in 2 wires. I've got basically some double lead, you know, just twin wire like that. They don't have to be twin, but I just had some laying around. Black indicates negative, red indicates positive. So I've got the black soldered to the baseboard here, and then I've got the red soldered to pin 14, remember 1 through 7, 8 through 14 of the 4066, so pin 14 of the 4066, and then I also go off over here to pin 4, 1, 2, 3, 4 of the 324. So that's going to deliver the voltage that makes these chips operate. And of course, it's no good having positive voltage without negative voltage. So now we have to solder the earth pin of these ICs to the board. There we go, done it. As you can see on the 4066, the earth pin is diagonally opposite the the voltage pin. So it's actually pin 7, pin 1 here, 7. So that gets soldered to the baseboard there. And on the 324, it is the pin that's directly opposite the positive. So it's pin 4 there, and it's 8, 9, 10, 11 on this side. And as you can see, all I've done is I've bent those wires over, bent those pins over, and then soldered them directly to the copper board. So that means we've got positive voltage, and we've also got the negative of the earth, the return path for that power. Next step is to run a wire from pin 6 on the 4066 all the way over to pin 7 on the 324. That's the white wire in this one here. So just from this pin on that chip all the way over to there. And if you refer to the diagram I did on the whiteboard, you'll see that you know, this is all covered by that. So just it's one of those connections that we saw on the whiteboard from pin 6 to pin 7. Now we have the grey wire, which goes from pin 1 over here all the way across to pin 6 over here on the same IC. So there's the grey wire. I hope you can see. I'll try and give you some angles so you can see what I've done here. Yep, that's straightforward enough. Now I've added a connection between pin 3 to pin 9 of the 4066 chip, and I haven't used insulated wire there because I'm running it across the chip itself, so just a piece of sort of, you know, any old copper wire would do. And I've left a bit hanging out here because this is eventually going to be our video out connection, so it makes it easier to solder on if I leave a little tag hanging out. Okay, here's where things might get a little bit tricky for some folks, because we're now adding the resistors, the 47k ohm resistors that are in the circuit diagram, and one end of one of the 47k ohm resistors goes onto this pin 14 of the CD4066. This is where our positive voltage comes in. So now you've got 3 wires soldered onto one pin, which can actually be a bit of a trick, because if you're not careful when you solder that on, another one will fall off, and then you try and solder that on and the other one falls off. So you just have to sort of practice, to have a go, see what you can do. It'll take a bit of farting around probably, but you'll be able to do it. Just, you know, persevere until you get it done. So that 47k ohm resistor comes along here, and then it goes on to the other 47k ohm resistor. I'll hold this up so you can see from the side. As you can see, that 47k ohm resistor comes along and it solders onto the other 47k ohm resistor, and that one, the other end of the second resistor, goes down onto our ground plane there, solders onto that. So where the two join, we then run a wire out from there, across here, all the way down there to pin 1, 2, 3, 4, 5 of the 324. So pin 5 is where the junction of those two resistors goes onto there, and I'll show you. I've done a bit of aerial work there. Hopefully you can see that it's sort of, you know, this wire here goes along and then goes down onto the pin. So just, I mean, you don't have to follow exactly what I'm doing. You can, as long as the points are connected, you're fine. But this is just the way I've done it. You know, it's one of an infinite number of possibilities. Now we add the two 4.7k ohm resistors, which are here and here. Probably can't see those too well. One of them goes to pin 2 of the 324, and one of them goes to pin 3. And I'll try and angle these around so you can see exactly what I've done here. I've run them out like that, because these are going to take the RSSI signal from our receivers, so we want them near the edge so we can solder other wires onto them. Now, these are just little ones I had laying around, so they're not necessarily, you know, bigger resistors would probably be easier to work with, but there you go. That's how I've added those, as you can see, and so you can do that now. Now I've added the brown wire, which goes from pin 1, 2, 3, 4, 5 of the CD4066 down to pin 1, 2, 3, 4, 5, 6 of this chip. I should have actually added that before I put the resistors on, because it would have been easier to put it in, but as long as you've got pin 6 of this chip connected to pin 5 of that chip, then you'll be fine. It's a little bit of farting around because, again, you've got to join 2 wires here because you've got the grey wire and the brown wire on the same pin. Of course, you don't have to use the same colours that I'm doing. I'm using different colours just to make it easier for you to see what I'm doing on a step-by-step basis. And now we're going to add the wires that go off to the receivers. I've just used some old servo lead here, which I've chopped up, the old extension leads. We can buy this stuff really cheap by the meter. It's really quite nice. I've used 3 colours, well, it's got 3 colours, black, red and yellow, and the convention I'm using here is the black will be the earth or the ground or the negative, all the same thing really. The red will carry the RSSI voltage that tells us which receiver is getting the strongest signal, and the yellow will carry the video from our receiver. So there's 2 receivers, of course, so I'm going to wire both those up. I'll show you how we do that. The first receiver is wired up here. I've got the yellow wire goes all the way off over here to pin, 1, 2, 3, 4 of the CD4066. and the RSSI signal goes onto the 4.7 k ohm resistor that connects to pin 2 of the 324. So hopefully you can see that, and of course the negative is just soldered to the baseboard here. The black wire solders to the baseboard. So there we go. Take a look at that. Reproduce this at home. Now the second receiver is wired up, and you can see I've wired the video to pin 8 of the 4066. The RSSI lead, the red one, goes off to that other 4.7 k ohm resistor that goes off to pin 3 of the 324, and again the black just goes onto the board there. So now both of the receivers are wired up, and we'll wire up our video output. For the video output, I've just used one of these old, you know, everyone's got hundreds of these little RCA leads. You get them with the old DVD recorders and DVD players and video recorders, you know, they're all over the place. So just grab one of those and cut it, and inside you'll find cable that has a screen, an outer screen cable, and an inner cable. And of course the screen, you can guess where that's going to go. That's just going to go straight onto the copper board, and the red wire goes to this extra lead we've got here, which comes from the 2 pins on that chip, which are pin 9 and pin 3. So that with 9 and 3 are joined, and that's our video output. So we just solder that onto there. So there we go. That's it. That's the Buck 29 diversity controller built dead bug, or as you can probably see by now, rat's nest style. It's also called bird's nest construction, because look at it. It's just looks like a real mess. In fact, the fact that these things work, when you look at how they're just sort of all screwed up and thrown together like that, is amazing. It's almost a piece of art, isn't it? Almost a work of art. So there you go. Of course, what I'm going to do is I'm going to put the LEDs on here to make this into the deluxe version. Cost you another 50 cents to make the deluxe version. And to do that, you'll need some LEDs. These are some I've had used for other purposes, which I've just pulled out of the system they were in. There's a yellow one there and a red one there. I'm going to hook these up, and to do that, of course, I'll need a couple of extra components. 330 or 390 ohm resistors. I've got one of each actually, so it's not even important that they're the same value. It just means they'll be a bit dimmer. One LED will be a bit brighter or a bit dimmer than the other. So I shall wire these in, and then we'll be able to check and see that it works, because these will tell us that the system is switching. We'll be able to see that the power's on, all sorts of stuff. So I'll wire those in, show you how to do it. Okay, what you need to know about these LEDs is that they only work one way round. If you put the positive on the wrong side, then they won't glow. So you've got to know which is the positive and which is the negative. And you can tell it because there's a little flat on one side of these LEDs, and that little flat indicates the negative side. So in this case, this is the negative side because there's a tiny flat. I don't know if I can, it's hard to get the camera to focus actually when you're doing this sort of stuff. So I'll try and show you, so I can get it to focus. Come on, focus, pay attention camera, there we go. Hopefully you can see the little flat there, which indicates that we're looking at the negative lead. So that means the lead that's long goes down to the copper board. So I'll solder both of them to the copper board, and then we'll put the resistors in to connect them up to the switching part of the diversity controller. The LEDs are soldered in place, and I've just bent the leads out so they're poking out over this LM324 chip, because we're going to have to use a resistor to connect up to pin 7 and pin 6, I think it is. So that one will go to one from pin 6 to that LED, and one from pin 7 to that LED. There it is, all done. Of course, because pin 6 is also connected to pin 1, I found it was easier just to drop the resistor down here. I'll move these out of the way. So you can see I've just dropped the resistor down from pin 1 to the LED on this side, and from pin 7 over here. This one comes out on a bit of an angle. It doesn't matter if it's on an angle, it's abstract free art electronic, or abstract freeform electronic art really, isn't it? So there you go. So this is the deluxe version. I guess now we should connect it up and make it work, but some words about connection. Obviously you're going to need some power. That's what these wires are for, these red and black ones here. And I'm going to run it from 5 volts at the moment, but you can run it at other voltages. I'm going to do a follow-up video very shortly which shows you how to actually set this up and how to, you know, make it work properly, or make it work to an optimal thing. And part of that will be discussing what sort of voltage we power it from. But I'm just going to run it from 5 volts because I've got a 5 volt supply here. It makes it nice and easy. And of course, we've got our other wires running out to our receivers here. And I've put a little connector on here so I can just plug stuff in and out, because I've got some receivers, and on the receivers I've put a mating plug like this. Now you could use servo connectors for this because it's just 3 wires for each receiver. The only thing to watch is you do get the polarity correct. So if you plug a servo in backwards, it doesn't really matter, but if you plug this in backwards, well, smoke could come out. So you want to make sure that it's very clear which way around it gets plugged in. Now I'm going to plug these in here. I've got one receiver there, and there's another one somewhere. Here it is, lurking on the bench. Plug this receiver into here, making sure it's, you know, black to black, red to red, yellow to yellow, like so. So now I've plugged my receivers in. It's hard to do this in a shot and look at them at the same time. So So I plug my receivers in, they go off to the diversity controller here. And just a little word about receivers, because most people will probably want to use either something like the RC305. This is the really cheap 5.8 gigahertz receiver, piece of cake. How do you wire it in? Well, that's not so hard either. Take the RC305 board out of the box. That's pretty easy to do. And when you do, you'll find that there's this silver tin thing in here. And diagonally opposite from the antenna connector, if you run, just draw a diagonal line there and count 1, 2, 3, 4 of these little solder blobs in, then that's where your RSSI wire goes. Just solder that onto there and then run it out of the thing. You can get your video from the jack plug that is on the board, or you can do what I've done, which is just tip the board over, solder the black wire onto there and the yellow wire onto here, and now you'll have video coming out of the lead and the earth wire will be all intact. That's what I've done to my RC305s. You don't even have to put them back in the case. In fact, they work better out of the case because the little regulator it gets better cooling when it's not bunged in an aluminum case. So that's all you have to do to set up your RC305s for working with the diversity controller. So we better check that the damn thing works. I'll plug it all in and we'll have a look. So here we go. I've got this set up now. Here's our little diversity board, our bird's nested dead bug diversity board down here. Probably just out of shot. I'll just back out a bit. So perhaps we get that in, because I want you to be able to see the oscilloscope as well up there at the top. Now, so here's our diversity controller with the 2 LEDs. Here's our LCD screen showing us what comes through the controller. And here's the oscilloscope. This yellow line here, when it's high, then the yellow receiver is working, and when it's low, the red receiver is working. Now we're getting fairly similar sort of signal levels here, so you can see it switching backwards and forwards, but you notice this flicker on the screen there. Didn't want that flicker on the screen, did I? So see a lot of switching, a lot of flickering there. I'll go for a bit of a walk outside the little workshop here, and you'll notice it should flicker quite a bit because we're in a metal building and there's lots of reflections. In fact, I don't know if my wireless mic will work too well. So I'm just taking a bit of a walk around here. Look at the mess. This must be Barry's area. There's plenty of mess in here. And now I'll come back and hopefully I'll have picked up a fair bit of that mess and so forth. Here's the outside of my studio for those who are interested. Haven't finished the cladding yet, but as you can see, that flickering is unacceptably high. So what we're going to do is we're going to put something called hysteresis onto the system, which will stop it from flickering backwards and forwards so very, very quickly. It'll mean you'll still get a little flicker, but it won't be anything like the levels we're seeing here now. So there you go. Suffice to say, we'll be adding an extra component. So there it is, the dead bug build of the diversity controller, the $1.29 diversity controller. It has some shortcomings at the moment, as you saw, flicker. We didn't notice that when it was on the breadboard, but it was noticeable once I built it up as a dead bug. But there are simple ways to correct that. I'll be adding another component in the next video which should dramatically eliminate that flicker, so that won't be a problem. It's another cheap component, it's a resistor. So I'll experiment over the next couple of days and get that sorted, then we'll put the video up showing you where to put that resistor, and you'll see the dramatic effect that it has on the performance of the controller, suppressing all that flickering. So there we go, it'll be adding hysteresis to the thing. A lot of people suggested, oh, you should add some hysteresis, and I thought, yeah, I should, but let's just see if it'll work without it. It worked on the breadboard, didn't work so good in the real world, so yeah, that's what you learn. That's part of the whole development process for these ideas, and that's why some of these projects take so long, because you start off with an idea, you draw up a circuit, you breadboard it, you test it, you're happy, you put it on a circuit board, and then something you didn't expect happens, so you go back to the breadboard, make a few changes, you make a new circuit board. It's okay now, but there's something else. So it can be an iterative process. It can take a lot of time, which is, when people say, oh, when's part 2 of this project, that project coming? Well, as you can see now, sometimes, there's a lot more time that goes into these projects than you ever see on the camera, that's for sure, because it's actually taken me 2 days to do that little build video. Partly because I had constant interruptions, people coming in through the door and, hey, and airplanes flying over, not landing but flying over, and all sorts of hassles going on. So it was a 2-day video, this one. So, oh man, and when you consider that, you look at the money you make from it, the hourly rate is measured in cents, but I don't care. It's all part of keeping you informed, giving you some interesting stuff to play with. And so if you've got questions, put them on the bottom of this video. If you want comments, just throw them on as well. If you want to see the next edition, which you will do, we've got a big storm coming in the next couple of days, so it may be a few days before I get a chance to actually make those changes and test them out. And then we'll do some flight tests, hopefully somewhere. We'll go somewhere and we'll do some flight tests to make sure that this thing works in the real world. I'll record the downlinked video through the diversity controller. You can judge for yourself whether it's worth $1.29. Oh, actually, it's going to be $1.34 by the time we've finished. So there you go. Thank you for watching this video. See you again soon on RC Model Reviews. Don't forget thumbs up if you like it so other people will find it. Bye for now, because I've got to go back to the bench.